Hey, what's up guys? Let's move on with what we started in the last video and let's move on to a more advanced kind of thing called projectiles. Well, projectile is a very basic kind of a thing because we try to use it in everyday of life. Let us consider that we are playing a game of cricket and the fielder has to pass the ball back to the bowler. So here we have a fielder here and he's trying to pass that ball to the fielder who might be standing here. So what we has to do is to be throw the ball towards him in a projectile motion. So when he throws the ball, the ball will go somewhat like that and will end up to the bowler. So this motion here is a projectile motion. This projectile motion was first of all looked into by this guy here. He was Galileo Galilei, which we all know by the form of law of inertia. So first of all, before we move into the basics of what the projectile motion is or the mathematics of projectile motion, let us remember all the facts that we need in order to discuss about projectile motion. Let us consider that we have this object here. This object has a vast amount of forces acting on it, right? Let's say it has a vast amount of forces acting on it like this, and somehow the net force that is acting on this body is in this direction. So what we have here is this is the F net, right? Now, so we have understood the concept of two things, that is the concept of force and the concept of momentum. And somehow by the use of this, which Newton has proved, we know that the force is the rate of change of momentum. Or if we give it terms in differential calculus, then it is dp by dt. Right. So this is one more thing that has to be understood, which is more important than any other fact here, rather than the fact of second law of motion, is that F net that we have, it is equal to the rate of change of momentum, rather than m is equal to m into a, which is the second law of motion. This is in fact where the second law of motion comes from, because if we consider that the momentum is equal to mass into the velocity, then we have d of m into v upon dt, which will be equal to mass times dv by dt, because mass is constant. Now we have considered that the relative motion, that relativity is not taken into this formula, so we can easily say that the mass is remaining constant. So what is happening here is, it is the force that is applying is mass times the change in the velocity, and as we know obviously that change in the velocity is equal to the acceleration. So from here we get the second law of motion, that is the F net is equal to mass times the acceleration net. Now the main equation that builds up this thing is this equation here. This F net is equal to dp by dt. This equation here, F net is equal to dp by dt, and this needs to be very well recorded. Now let's move on and talk about a little about vectors. When we are understanding the concept of projectile motion, it is important that we look into a more 3D or a 2D type of motion. So we need to understand the concept of vectors. Now a lot of people were saying that vectors are really very tough to understand, but you need to understand the fact that vectors are very easy to understand, because vectors are just a quantity which we study in everyday life. Vectors are a quantity that gives our direction and the magnitude, and that is what it's all about. So like there we have an arrow kind of a thing, but we can say that in case we name this arrow as some a and we put an arrow on the top of this a, it will become a vector. So if this arrow try to represent any quantity and this quantity has a direction and a magnitude, then that is a vector. So if in this world there are a lot of quantities, then these two mainly quantities like physical quantities, then these two quantities can be of two types, that is vector or it can be a scalar quantity. So vector quantity is those quantities which have a direction as well as magnitude, whereas scalar quantities only have a magnitude. So when we are talking about a projectile motion, then we need to move into two dimensions, and thus we need to move into the fact of the vectors. Now We can also use vectors in 1D motion too, because if we consider the fact that we listed in all those 1D motions questions that we have used the front direction to be positive and then this direction, the opposite direction, to be negative. So can't we say that the front direction, if it is like, if you consider this to be a vector, then the opposite direction can be considered to be a negative vector, right? If you consider these vectors, this vector theory, right, if we consider the basics of vector theory, then it is very important to understand that vector theory goes onto a specific rule that if a direction is given like this, then the opposite direction has to be negative, because we have moved to a direction of 180 degree, right? And what is cos of 180 degree? Cos of 180 degree is 1 minus 1. So we have to multiply it by minus 1. So that is the main concept of vectors here. So whatever the magnitude may be, but if the one of the direction is taken to be positive, then the opposite at least 180 degree of that direction has to be negative. So that is the main concept of vectors. Now, if we move on, let's consider the same vector here we have. Now, what we do is, let's divide this vector into two rectangular components. What we do is, we take a rectangle and we try to construct a rectangle like this. Another one would be good. Okay, now another. Okay, let's take this approximate vector here. Okay, so what we have here is this vector, or this arrow is the diagonal of this rectangle, right? This may look as a square, but it is not a square. It is a rectangle. You can say that. Now what we will do, let's take this angle here as theta. So we denote this angle as theta, and what we do is, we take this length, right? We take this length and we take another length, this one, right? So let us suppose the magnitude of this vector here is some d, right? Let its magnitude be some d, and let this length of this rectangle, let's say, be L and B, which is the length and the breadth of this rectangle. Now from the Pythagoras theorem that we have studied, this will be equal to L square plus B square is equal to D square. So from here we can get the magnitude of L into B. Also, if we consider this to be a right angle triangle, because it's a rectangle, that means it's a right angle triangle, then we can say that D upon L upon D is equal to cos theta. Therefore L is equal to D cos theta, and similarly we can also have B is equal to L sin theta. So that is so obvious of the fact from that right angle triangle, but that has a very large meaning rather than being the length of the rectangle, the length and the breadth of the rectangle. From here we get to notice that if I consider this line here, then I can resolve this vector into two directions as well. I can resolve any vector into two rectangular components, and if in this condition I take this in a graph, let's say I consider a graph like this, right? I consider a graph like this and I draw a vector here like this, then what I can do is I can draw a rectangle which will contain this whole thing, and if I consider this here as the y-axis and this here as the x-axis, that is this is the y-axis and this is the x-axis as a normal coordinate graph, then I can resolve any vector into the x-axis and into the y-axis by just saying that in the x-axis, if the magnitude here is d, then here will be d cos of theta if this angle is theta, and in the y-axis there will be d sin theta. So what we have done actually, if the motion is in 2D motion, then we have resolved this into two one-dimensional motions for our calculation purposes. and it will be a very easy thing to understand if we do it in this kind of thing. So rather than considering a very complex 2D circumstance, we have done a very easy 1D circumstance. So this is the basic concept of vectors that we'll be using here. Now let us move into what we will do in projectiles. In projectiles, we will consider that a ball is being thrown. Let's say that this ball is being thrown here, right? So we have a ball being thrown in this direction. And by the common sense, we know that this ball goes by the direction like this. Like somewhat like a parabola, but I won't say a parabola, right? It will go in a half circle, in a semicircle, a parabola, a hyperbola, I don't know. But it will move in this kind of a direction, which we know by common sense. Now let us suppose that the cricket match is going on, the bowler throws the ball, the fielder throws the ball towards the bowler and the bowler catches it. Now how does the fielder know that the ball will reach there? By which circumstances does he know that? In case the fielder is a scientist, then what will he think in order that the ball reaches to the hand of the bowler rather than dropping in front of him? So that is what we want to understand in the mathematics of projectile. So what we are trying to see is what type of forces act when this ball goes to the bowler, how his motion is being affected by these type of forces, and how is it reaching the bowler. So for this, we will again draw this ball, right? And we will draw the let's say a path which might be its path. We'll draw a path which may look like its path, right? Let's suppose this is the path. Okay, like this. This is the path of the ball, right? And at this position, the ball is at, say, I have thrown the ball at t equal to 0 and it has reached at t equal to 1 second. Now let us draw the free body diagram of this ball. The free body diagram means that I will draw the various forces that act on this ball at this point of time. So at this point of time, we say that there is no air resistance. We try to assume the fact and try to make it more simple rather than going to complex, and we say that no air resistance is applicable, no friction is there. So the only force that is acting is the act of gravitational force, and which we know by the fact that using F is equal to ma, where the acceleration is the acceleration due to gravity, g is equal to 9.81 meter per second square, that there will be one force acting downwards. That's it. This is the only force that is acting downwards. So this force will be mg. Right. Now let us go back to the initial situation. In the initial situation, the ball has been thrown into some direction. Right. It is important that if it needs to reach the bowler, it has to be thrown in some direction.